For half basic physics, I'm sure you've seen these already. So displacement. So remember, displacement is how far you are from where you started. So whether I walk forward or backward, like how far you travel from where your starting point is, that's what displacement is. But distance would be like you actually calculate how much I actually walk forward, actually how much I walk back, and then put that together. And so that's the absolute value. So if you look at the formulas here, displacement, it's like you're accumulating how far from where you started from to where you're going. If I take the integral of the velocity, that represents the displacement. So a lot of the stuff that you're going to see when we start looking at application problems with, I guess I'll write over here. More of y'all over here. Oh, maybe. All right. So a lot of times what you see is you'll see like the graph of f. Let's just say. All right, or the graph of the derivative that you end up seeing. So you might have some graph that has some wonky curves or something like that. So let's say that's your derivative. All right, and then this x-axis represents time. All right, and let's just say that this is the derivative. So we're going to say it's the velocity. All right, so if this is our velocity function, what's the y-axis represent? Yeah, whatever unit, so meters or feet or whatever the case may be per second. So you're going to have time down here, right? But then over here, so let's just say this is in seconds. And then on the y-axis, you're going to have like feet per second. Or you're going to have meters per second. All right, depends on what kind of formula we're working with here. And so if you think about it, when we talked about integrating, we were finding the area under the curve. All right? So when you first started talking about this, we started talking about like finding rectangles. And so when you found the area of each rectangle, you were finding a width and you were finding a height. Well, if you look at it, the width is time. The height is
something divided by time.
Yeah, something divided by time. So if I multiply those two together, you get
just whatever.
Whatever the units are, the distance, the meters or the feet. So when you talk about displacement, if I'm saying we're starting at 0 and I'm ending at 3, like what's the displacement? So how far are you from where you started? Well, if I accumulate all those areas of the velocity over that amount of time, when I integrate that, you're finding an actual length, like a distance. All right, and so that's why displacement, you would take the integral of the velocity. It's because you're finding the area under the curve of the velocity, which the answer that you get in the end is either in meters, feet, whatever the case may be. All right, but some unit of distance. But then if I said, hey, what's the total distance that you traveled? Well, sometimes you might be above, sometimes it might go down, below into the negative, whatever the case may be. Again, like if you found the total there, well, you'd have positive up here, you'd have a negative down here, but the total amount of distance that you traveled, you would just think about this as like if I said this was 10, let's just say, and this was negative 2. Well, total distance you traveled 12. But displacement-wise, how far are you from where you started? That's 8. All right, so remember, just like what we were doing before, like if I stood here and I walked 8 steps forward and then 8 steps back, my displacement would be 0 because I'm not any further from where I started from. But distance-wise,
that's 16.
That's 16. So you got to keep that in mind. So that's why distance is the absolute value, because you care about that positive number. All right, so these two formulas are going to come into play as we kind of continue with this. All right, and then the bottom two down here, well, position, if we know velocity is the derivative of position, well then position is the antiderivative of velocity. And then the same thing for velocity and acceleration. So the antiderivative of acceleration would be velocity. So again, just going in the other direction of what we're dealing with. All right, so these four are the ones that are on your sheet that are a little bit new that you'll have to kind of get used to. All right?
Okay.
Somebody recently told me, it might be somebody in this class, I don't remember who it was, but they said, if you are born and you die in the same hospital, then your velocity in life is 0. Or like your displacement.
Yeah, your displacement.
Your displacement.
And if your displacement
Well, it
is 0,
is.
then your velocity is 0.
If you were born
Oh.
in the same like
That's
You die in the same hospital. In the same room.
The same bed.
Hopefully they. Well, I guess.
Where does it have to be?
Just an area.
Well, actually, but you're on
Let's
Earth,
think
and
about
Earth
this.
is moving. So really, that wouldn't be the same.
But maybe
Yeah,
it's,
that's-
it's the same
The
spot.
that doesn't make sense.
It's on your
Why not?
birthday at
Well,
the same time.
If you're like, if your point of like reference is the Earth, which it should be, because like,
Which
well,
it
if you
should
were, like, if you
be.
were running like a marathon, you wouldn't like run the marathon and be like,
I'm
all
gonna
right,
pause
how
the video
far
right now.
is
This is
it?"
stupid.
I got you. Yeah.
It's like,